So let's review some concepts to understand how all of this works together. So the first one is a resource, which is a cloud component like a virtual machine, an IAM user, an EC2 instance, or in this specific use case, I'm using an S3 bucket. Panther scans all these resources and then models them as JSON objects, which you can see right here. The resources are then passed into policies, which are Python functions representing our desired secure state. This function will return true if our resources are compliant or false if they're non-compliant. And we can do any type of logic that we want in these policies, which is extremely flexible. And you can use all of Python's power to really determine if our resources are compliant. The final concept is an alert. So if we see that our resources are non-compliant or not secure, we'll send notifications out to our team to go triage this, fix it, take a look, and remediate this security hole. So to enable this pipeline to work, we create a set of IAM roles that connects your Panther deployment to all of your other accounts. And Panther can support as many accounts as you have. This could be tens, dozens, hundreds. And the beauty with Panther is that it can really act as this centralized place for all of your resources. So this goes for searching, but also for evaluating if they're secure or not. Panther also uses the information that you collect about your accounts, such as the account ID, the account name, in order to group these resources to better understand the posture across our various environments. And after onboarding into Panther, we'll perform a baseline scan to get the entire range of resources in the accounts, and then we'll evaluate those resources against our built-in 100+ Python policies. And these are all open source, by the way. So the code's freely available in GitHub. I'll show the links at the end. But these policies cover best practices in Amazon. They cover the CIS benchmarks, which are just really great foundational checks that everyone should be doing to prevent most of the common breaches that we see. We break these out into specific categories around, is this policy around security control? Is it around protecting our data? Is it about availability, et cetera? And this is just a great place to start. So after our detections run, we start to populate our overview page. And this overview page gives a breakdown of the policies that we have running and the resources in our system, and it focuses our attention on the ones that have the highest failure counts. So let's look at this example S3 bucket, and let's go through a normal triage workflow. So as an analyst, what I would do is I would come to this page, and this is if I'm just more generally browsing around and I want to just improve the overall system versus having a specific thing I'm looking for. So let's go through this workflow. So we click into the resource, and now we get attributes about the resource, along with which account it came from, what's the full ID of the resource, and all of the attributes associated with it. And this allows us to understand the current state. If we keep scrolling, we see the associated failing policies, and we get options for auto remediation, ignoring, et cetera. So let's hone in on one specific policy. Let's look at bucket encryption, which is a really helpful data protection technique we can use. So clicking into this policy, we get all the context about why this policy exists, how do we handle failures, what's our runbook, why does it, or how do we tag this policy, and we can actually see the resource that we just came from here. So our cloud security component has this ability to backlink between resources and policies, which provide a really nice intuitive workflow. And we also can, add remediations to our policies. We can add patterns for resources that we want to ignore. And if we want to actually just go through and edit the Python, we click our edit button at the top, and then we're dropped into our policy editor. And the policy editor allows us to modify all the metadata that we just saw in the previous page. And it also allows us to just write Python purely in the browser. And we can ensure that this Python works by using tests. So if we keep scrolling down in the editor, we have this ability to copy in a sample resource which has all of the modeled attributes that we would want to determine, would this resource be true, evaluate to true or evaluate to false? Meaning, is it compliant or not compliant? And all this, as I said, can be done in the browser.